Hi, today my team and I, we will be talking about the annuity topic. First of all, the annuities, they're a type of investment in a long term, or as well you could call them as long-term insurance for life. Some examples of it are regular deposits in saving accounts, monthly home mortgages payments, and monthly insurance payments. So in other terms, we could say that an annuity is a sequence of payments made at a regular time intervals, meaning that it has a period of time in which it will be taking on, and once let's say you make a deposit, there will be two outcomes, which is the present value and the future value, which my partner will explain later. And so there are, as I mentioned, there's two types, the present and the future value, and as well there's the simple and the complex annuity. The simple annuity is when the payment and the interest conversion coincide, and the complex annuity is when the payment and the interest conversion differ. So they have a definite beginning, a definite date when they begin, but they have an indefinite date when they end. And it is important to remember that there's two important things called the end and the beginning, which is in the end it's an ordinary annuity, and in the beginning it's the annuity due, which could also be referred as the future value.
Okay, so we use two different types of formula. The first formula is the present value formula, and what you do is R1 minus 1 plus I, and with I you do the rate, let's say 0.03, so at 3% it's 0.03 divided by the period, and period is monthly would be 12, semi-annually would be 2, quarterly would be 4, and annually would be 1. Then minus n, which is a period. After this, and then you divide it by the same thing. This is the present value. Then the future value is similar, but you do R1 plus I and minus 1. This shifts this, and yeah. And this is not negative. And sorry, this is not negative. So future value, present value.
Hi, my name is Hernandez, and today we will be solving a future value problem. Here we have the equation, and basically what the problem is asking us is to find the value, or the future value, of the ordinary annuity. And here they're giving us four values, in which they're saying that you have to pay $900 a month, which is also known as our R on the equation. 15 years time at 7% per year, which is our rate, compounded monthly. And I think that it's important to remark how monthly, or depending whichever word they're giving you in terms of time, whether it's monthly, quarterly, etc., you need to know what number that word represents. And in this scenario, monthly is going to be represented for 12 months per year. Now, basically, now that we have our four values, we're just gonna plug it into the formula. So it will be like this: S equals R, which is our 900, parentheses 1, and once you finally plug in all the values, your answer will be $285,266.07.
Right now, I'll show you how to solve an ordinary present value annuity. Let's suppose that you have $140 per month for 12 years at a 4% rate per year compounded monthly. For us to understand what we have to do, we have to take a look at the formula and understand which values are what. This is a formula, and in this case, we have to use negative n times t, because the problem is telling us that it is happening more than 1 year. So you have to multiply them by the number of years. So, yeah. Then we have to list what we need for the formula with the values given. We know that our capital R is our investment or deposit in the account, in this case, the $140. Then our rate is clearly shown in percentage in the problem, so is the 4%, which is the same as 0.04. Afterwards, the n is the number of periods in which the rate is exposed. In this case, since it says compounded monthly, we know our n is 12. And lastly, our time is clearly shown in the problem as 12 years. After we clearly understood what every value is in the formula, the next thing we have to do is plug in the values in the formula like this. At the end, we put the formula in the calculator and we have our result. In this case, our present value is 15,990.34. Thanks so much for watching, and I hope that you now know how to solve the present value.